This is our final project.
It's zero shot sports event categorization. We specifically chose 4 sports: tennis, F1, soccer, and the UFC. We had as inputs events or actions that might be unfamiliar but that describe the sport fully. And as an output, we decided to categorize those events into 5 categories. And as you can see at the bottom, we're going to add a demo at the end of this video to show that functionality. We think it's important. If people don't know what a sport is and want to get into the sport, they better know what the terminology is so they can understand what they're watching. So we believe that this approach would help them understand the sport better.
Okay. For data collection and curation, each of us picked one sport to collect data on, those sports being soccer, UFC, Formula 1, and tennis. We split each event type into 5 different categories, so offensive, defensive, error, neutral, and transition. So each sport had events collected from various websites and GitHub repos. So the goal for each sport was to collect 300 events, and this was to make sure that the embedding layer was able to actually learn the structure, and the MLP was able to just not memorize IDs, as well as for the PCA to have enough data to display.
So to create our ML model, we first had to create our features. And for our features, we created an event vector with IDF weighting to give more high weighting to rare words in our dataset. And we also had a sports vector as well, all from our .csv data. And then we compared 3 different models. We had 2 baseline models, a logistic regression and linear SVM model. But eventually the main model that we used and found that had the best performance was a multi-layer perception model. All of these models are non-linear because we recognized that non-linear models would be necessary for our ML problem. And basically we chose the multi-layer perception model because we found it had the best single run test accuracy, as you could see from our plotted data. And so for our MLP model, it had 2 things: a word embedding dimension and sports embedding dimensions, each of 16, a hidden layer of 64, a dropout of 0.5. It used the atom optimizer. It had a learning rate of 0.005, which we then used the scheduler to reduce if the validation accuracy plateaued. We added a weight decay of 5 to the -3 and epochs of 100 to loop through the MLP model, all for our training. So after we decided that our MLP model was the best model to use, we did some qualitative analysis on it. So we did PCA analysis by generating 2 PCA plots, one for displaying the event embeddings with the sports overlaid on top of it, and another one for the event embeddings with the categories overlaid on top. And as you can see here, for example, on the PCA plot, you can see that F1 is a pretty different sport compared to soccer, tennis, and UFC, which is why it's so far off. So through our plots, we could see that the MLP was a good choice. Another analysis we did for the MLP model was KNN analysis. So we did 3NN analysis to see how similar the sports were that we used in our data set. So we found some interesting stuff about which sports were more similar to others, which eventually led to how that model would make its predictions. And so as you can see here, this is our application, a Gradio application showcasing our actual goal for the project. So if I type in something like spike, that's a volleyball term, then it'll correctly classify it as an offensive sport term.
Alright, so in conclusion, we got that our MLP can categorize events from unseen sports by relying on semantic similarity rather than sport-specific rules. So we had our data from 4 specific sports, but with our model, the user is able to put in any details of any sport, and it could guess exactly if it's an offensive, defensive, or etc. move. We also found that the MLP was outperformed the linear models. It was 2%, but it was pretty consistent throughout all the different testings. And using IDF-weighted word embeddings, that made our features more meaningful, which created clear category clusters and meaningful relationship between sports and events.
Thank you.